Nelson. I'm from the Optics Climate Action Network Existing Buildings Group. Before I introduce the first speaker, I want to give those of you who are familiar with ACAN a little bit of background about ACAN. We're a network of individuals in built environment professions who are taking action to address the twin crises of climate and ecological emergency. But we've recently become a community benefit society. If you want to find out more about our campaigns and about our working groups, have a look at the ACAN website. It's architectscan.org. This is our program for this evening. And our first speaker is Peter Rickaby, who is joining us virtually. Peter has had 35 years experience as an energy and sustainability consultant in buildings and housing. He's now semi-retired and is currently working as a specialist retrofit consultant for Savills social housing team. He's also an honorary senior research fellow at University College London, where he helps to run the UK Centre for Moisture in Buildings. He chairs the BSI Retrofit Standards Task Group and was technical author of the new Retrofit Standard PAS 2030-2019 Retrofit Dwellings for Improved Energy Efficiency. So over to Peter.
Thank you, Susie. Good evening, everyone. It's great to be here and talk to some architects. So what I was asked to do this evening is to talk about PAS 2035. I seem to have done that at least 1,000 times in the last 5 years. So I'll try and give it a bit of spice, but it's a story that's quite long and complicated, and I'll try and compact it into 20 minutes for you. So I want to start with a load of failures. Not a good place to start, but it's the reason we have PAS 2035 are failures like this. All of them during the last 10 years or so, the last decade or the 20 teens. Most of you will have heard of the Preston failure, 300 houses made uninhabitable by poor EWI. In fact, it's not the only scheme like that. There were other similar problems in both at north and south ends of Wales, in Hull and in Middlesbrough, amongst others. There were some failures in Scotland in 2014, mostly to do with a particular big storm, which caused some collapses of retrofitted buildings. There was, of course, the Grenfell Tower, which you will all have heard of, and is still with us and still producing new revelations and new misery today. And then what probably most people haven't heard of is that there were numerous insulation failures in the period 2010 to 2020. I'm not talking a few hundred, I'm talking a few thousand, and they were mostly following poor installation of cavity wall insulation or external wall insulation or inappropriate installation. So that all led to a review, which many of you will have heard of, some of you will have participated in, I'm sure, and that is the Each Home Counts review. It was industry-led, but sponsored by 2 government departments, led by Peter Bonfield from BRE, had multiple work streams and involved hundreds of people who gave their time up voluntarily for about 18 months to work in those work streams. It produced 27 recommendations, and the focus of Each Home Counts was on the consumer. It was about standards and enforcement and consumer protection and consumer advice. Of the 27 recommendations, I'm only going to deal with the quality and standards ones, because that's really where PAS 2035 comes from. And then you might think that Each Home Counts has disappeared out of sight or sunk without trace. In fact, there was a 3-year period when it was being implemented by a cross-industry implementation board. I was a member of that board, and BEIS has to date spent at least £3 million and recently promised to continue to fully implement the review. So we are on a journey with Each Home Counts. The review had 2 strategic objectives in response to those failures we started with. One was to boost demand for retrofit by restoring the trust in the industry on the part of consumers, housing organisations and government, and also reducing the risk to finance bodies to encourage them to fund retrofit, because of course the government's always been quite keen not to have to fund it all itself. But finance is only available if risks are reduced. And in fact, I remember being told by a banker from BNP Paribas that they had lots of money to put into retrofit, provided we de-risked it. And I was at pains to tell them we couldn't de-risk it, but we could manage the risks for them. What Each Home Counts does is it establishes a quality assurance framework to support the industry. And that quality assurance framework's key components are Trustmark, which we'll come back to, and the BSI Retrofit Standards Framework, which we'll also come back to. What Each Home Counts also does is try to promote the consolidation of an industry, an energy efficiency industry, which until recently was fragmented into lots of little businesses that were installing one or two measures each in housing and not doing whole dwelling retrofits. So part of Each Home Counts is to encourage adoption of new business models focused on whole dwelling retrofit. The quality and standards stream of Each Home Counts was the BSI Retrofit Standards Task Group, which I was the co-lead on that strand of work with Claire Price from BSI, and subsequently I took over the chair of the Retrofit Standards Task Group. And I think it's quite important to point out that although the task given to us by Each Home Counts was to develop a framework of retrofit standards, and I'll explain framework in a few minutes, the objectives were very wide, and they largely came from a late friend of mine called Neil May, who put a lot of work into getting these objectives right. And note that they're not all about energy efficiency. There's stuff in there about function and durability, comfort and well-being, environmental impact, architectural heritage, performance gap, and unintended consequences. So the spread of the Retrofit Standards Task Group and of the framework is quite wide. And we also adopted two principles. One was to focus on outcomes, not on people. Certifying people's competence is not good enough. We want the outcomes to be right. And also to combine technical standards with guidance so that we weren't just putting out dry, expensive books from BSI, but providing useful guidance. This is a diagram of the BSI Retrofit Standards Framework into which PAS 2035 fits. So if we start at the top in the middle, the Each Home Counts quality mark became Trustmark, a government endorsed standards body, and they were entrusted with being the public face of quality in domestic retrofit. And they're supported by the Each Home Counts Code of Conduct and the Each Home Counts Customer Charter, both written by Liz Mail, both now owned by Trustmark. The Code of Conduct is about how the industry should behave. The Customer Charter is about how the customer, or what the customer can expect and not expect from us. Retrofit programs that are subject to Trustmark or Trustmarked, and they're mostly government funded or promoted, are required by Trustmark to comply with the big box in the middle, which is PAS 2035, my subject tonight. And PAS 2035, retrofitting dwellings for improved energy efficiency, specification and guidance, is the overarching UK domestic retrofit process standard. What it does is it sets out a process which, if you follow it, should result in minimization of the technical risks that we had found to be associated with domestic retrofit and minimizing the things going wrong. But the point of it being a framework is that PAS 2035 also refers, at bottom left, to a whole load of existing BSI standards, including PAS 2030, which is the installation standard, BS 5250, which is the moisture management standard, BS 7913, which is about traditional and protected historic buildings and how you might retrofit them. And on the bottom right, to non-BSI standards, including the insulation industry standards and the MCS standards, amongst others. And then in the middle are new BSI standards still being developed by the BSI Retrofit Standards Task Group. There's an assessment standard on the way, there's an air tightness and ventilation standard on the way, there's an energy advice code of practice on the way, and we've just finished or just published last year a building performance evaluation standard. So the point of this being a framework is that once a project or a program is trustmarked, every relevant and current standard that we've got is brought to bear on it. So it's a way of bringing the whole family of standards that we've got across the industry for retrofit to bear on those projects in order to make sure we don't have any more of those failures that we started with. So this is PAS 2035. I'm sure many of you will have seen it, some of you will have read it, many of you will have referred to it, I'm sure. This is the simple flowchart from one of the early pages, and I'm going to just quickly zip through this in a very cursory way and then give you a summary of how PAS 2035 works. So after inception and some advice, there is a risk assessment, which divides projects into high, medium, and low risk, and they follow respectively paths A, B, and C, 3 separate paths through the standard, through the PAS. There is then a whole dwelling assessment, which includes an assessment of the existing ventilation and a significance assessment if the building is traditionally constructed or protected under BEIS 7913 to find out what its particular characteristics are that we need to think about. There then follows an improvement option evaluation. The purpose of that is to determine what are the best measures to apply to this dwelling to get it where we need it to be by 2050. So it's looking at the horizon and looking at zero carbon. How do we get this dwelling to zero carbon? What are the best measures to do that? And that then underpins a medium-term improvement plan, which is how do we get there from here? A staged plan from getting from where the dwelling is now to where it needs to be in 2050. All of that is agreed with the client alongside some advice and becomes then sent to the designer for at least the first stage of the medium-term plan to design and specify it. And the design and specification requirements are by far the largest part of PAS 2035. I'll come back to design a little later. Once we have a design, it's passed to an installer or a contractor. And the contractor or installers must work under to PAS 2030, the installation standard, or to the Micro Generation Certification Scheme, MCS standards, as appropriate. And they're responsible for installation, testing, commissioning, and handover, including handover advice. Once that's all been done and the building has been retrofitted and that's first stage work is complete and handed over, there is an evaluation stage. It's officially called monitoring evaluation. I think it's really more evaluation than monitoring. The purpose of which is to find out whether the agreed intended outcomes at the earlier stage, just after the improvement option evaluation, have been achieved, and whether there have been any unintended consequences during the course of the work. And provided the answers to those questions are correct, that the outcomes have been achieved and there have been no unintended consequences, the project is complete and can claim compliance and move on. If the answers are wrong, then there is a further escalation of the evaluation process to investigate the problems and remediate them. So that, in a nutshell, is what the process that PAS 2035 promotes. To summarize it in a slightly different way, a few key points. First is that all projects must have a retrofit coordinator, which is, of course, the main topic of this evening. There is a minimum professional qualification for retrofit coordinators, a level 5 diploma, but all the other roles in retrofit in PAS 2035 also require minimum qualifications, whether they be assessors, advisors, designers, or so on. There is a risk assessment, as I said, based on pre-dwelling assessment data, which determines the path through the PAS. And the required qualifications for the professionals actually depend on the assessed risk. Then there is a whole dwelling assessment, which covers 6 topics. It's way more extensive than an eco assessment or a Green Deal assessment or energy performance certificate, EPC assessment. It covers the context of the building, both legal and geographic, the condition of the building, structure and damp and so on, the occupancy and the vulnerability of occupants, the energy performance in the normal way, catching SAP data, the existing ventilation system, and the historical or cultural significance of the building. Then there's a design process which starts with the improvement option evaluation we've talked about to identify required improvements to 2050, and a medium-term improvement plan to establish a staged process for getting there. There are then extensive design requirements, including attention to moisture management, thermal bridging, thermal bypass, interactions between measures, and so on. And there are additional requirements if the building is traditionally constructed or is a protected building. For ventilation, the existing ventilation system has to be assessed as part of the whole dwelling assessment. And if it's deemed to be inadequate according to certain criteria, then it must be upgraded. Or if it will become inadequate because of the retrofit work, it has to be upgraded. Installation, as I've said, has to comply with PAS 2030 or the MCS standards. And then we have finally the post-completion evaluation process, where essentially we check, did we do what we said we'd done, and has anything surprising happened? And we investigate discrepancies and any unintended consequences. So we're trying to close the circle with the evaluation process, which is interestingly something that the retrofit industry, or the energy efficiency industry, had never done before. It had never agreed outcomes with its clients, because most of the clients were not the householders, they were the funding bodies or the energy companies, and they never checked afterwards that they'd actually achieved them. So we're trying to get the energy efficiency industry with past 2035 to do what any industry worth its salt would do, which is to check with its customers whether they're happy at the end of the process. So to sort of summarize the quality assurance system into which past 2035 sits, we start, as I did this evening, with those failures, which occurred around the same time as many of us who were architects doing work in retrofit were learning from programs like Retrofit for the Future, from the Centre of Refurbishment Excellence Core in Stoke-on-Trent, from the GLA Renew program, and other schemes where we were learning what could go wrong and why it could go wrong and how, and what to do about it and how to manage the risks. And that led us into the Each Home Counts review, and that led us to Trustmark, the retrofit quality mark. Trustmark has two arms to it, if you like. One is compliance, auditing, inspections, enforcement, remediation, and redress. So that's to do with enforcing the standards, and in particular past 2035. And it also has a data warehouse where records of all past 2035 compliant retrofits have to be uploaded. Past 2035 is a requirement of Trustmark retrofit programs, and past 2035 itself, through the framework that we've discussed, brings in lots of other standards. So it's not just past 2035 as a process, it's all the standards that we know about that are valid and relevant to the project. When it comes to installation, we have to install in accordance with the MCS standards or past 2030 or both, and records of all that work get uploaded to Trustmark, who can use the data in the data warehouse to risk assess what they audit and inspect, but also for research into how people are doing and who's cheating and things like that. And then all of this stuff in the grey box is part of the retrofit standards framework that we saw earlier and is continuously evolving, having new standards added to it, which will appear in this box as we go along. So that's kind of where we've got to. It's not perfect. There's lots of weaknesses and lots of things wrong. So I wanted to finish with a couple of slides on what we're going to do next with past 2035. So we now have an annual update program agreed with BEIS and to some degree funded by them, but run by BSI. And for the update in 2022, we've been looking at current weaknesses. I think there's a general view that past 2035 is too focused on officially promoted retrofit programs and not that great for owner-occupiers for whom it's too complex and expensive. And it's quite difficult, as SHDF Ways 1 has taught us, to apply at scale, although that's certainly one of our priorities for improvement. The sort of objectives we have for updates of past 2035 are these, and they're all about continuing in the direction we have been traveling, strengthening the protection of homes and of occupants' health against bad retrofit, strengthening the focus on whole dwelling retrofit in planned stages rather than on incremental measures, strengthening of the role of past 2035 in moving dwellings towards net zero carbon, improving the applicability of the standard to scale retrofit by allowing a focus on dwelling types, which are used by many housing organizations, focusing for the future on retrofit contractors, to whom retrofit installers will become subcontractors rather than directly on installers. So moving to a more conventional structure in the building industry, adapting the PASs to the special requirements of the devolved administrations, and we have quite a lot of requests or asks from the Scots in particular, and finally correcting known technical errors and inconsistencies. So kind of my final slide is about what we're going to do in the first 3-year program of planned annual updates. And the 2022 updates look like this. Strengthen the role and independence of the Retrofit Coordinator. We've clearly identified that the Retrofit Coordinator, if employed by an installer, has a conflict of interest. We're going to review the risk assessment criteria. We might even remove the risk paths altogether and just have one standard with one path through it. Move from retrofit installers towards whole dwelling retrofit contractors. We've already talked about that. Provide for the use of dwelling types and subtypes in scale retrofit. What some of the work I'm doing with Savills is absolutely about the detail of that, how we look at dwellings in ways that housing organizations look at them and perhaps make them a bit more granular in order that we can focus retrofit very quickly on what they need to do. Assimilating the BEIS retrofit technical guides, of which you may know, there are about 5 of them now and more coming, which are technical guides to things like internal wall insulation, floor insulation, room in the roof insulation, and so on. And we're going to put those in as normative references. In other words, complying with those guides will be a requirement of PAS 2035. We're going to follow up the significance assessments in PAS 2035 with heritage impact assessments. Significance assessments tell you that the building is significant, but they don't tell you what to do about it. Heritage impact assessments allow you to assess the measures you're proposing for a dwelling against the significance and see whether they're appropriate and, if necessary, adjust them. We're going to introduce a procedure for validating and assimilating new measures and new innovations into PAS 2035, probably via a new annex, which will set out a process that promoters of new measures have to use to validate their claims. We're going to focus on whole building retrofit rather than whole dwelling retrofit. And that's a subtle distinction, but one that's come from David Weatherall in particular at EST, that where we're looking at blocks of flats, for example, why not retrofit the whole block rather than just focus on individual dwellings? There are some challenges in there to do with leaseholders, but I think we've got a grip on them. And then finally, we want to improve the alignment of Annex C, which is about ventilation, with the new building regulations approved document F, which has a lot of very big weaknesses, but I think we need to do a little bit of work to make them come together. Now, all of this, I have to say, is subject to the approval of the steering group. The steering group is a group of currently 55 people, but will be reduced to 15 to make it more useful. And so everything I've said will only happen if the steering group agrees. And we're currently populating a new steering group with 15 key individuals. So that's all I wanted to say this evening. I've probably used my time. I'm sure there'll be questions, and I guess we'll have those in the panel discussion at the end of the event. So thank you very much for listening, and I'll hand back now and unshare my screen.
Very comprehensive explanation of PAS 35. Okay, so next we've got Bob. Bob Pruitt is an architect and director of Pruitt and Bisley Architects. Since 2008, his work has focused on deep, low-carbon retrofit, much of it for private homeowners. In 2010, he coined the term Retrofit Coordinator as part of a set of guides on domestic retrofit. Retrofit Coordinator is now an industry-accepted role and underpins PAS 2035, which he contributed to as part of the original steering group. Rob continues to focus on private retrofit, but also contributes to larger scale projects and strategic advice, such as the London Retrofit Action Plan. So over to you, Bob.
Thank you. Thank you, Peter. For, I think you were spot on time, actually, and you were, as usually, succinct and concise. I will try to be as obedient. And thank you, everybody here coming along. It's nice to see people in the room again. And thanks everybody who's online for joining us too. And finally, thanks to ACAN for inviting me. It's a pleasure. It's an honour. I think your organisation is doing really great stuff. So I was really flattered to be invited to this one. So I'm going to talk about the work I've been doing on one-off homes for private homeowners. As I said, feeding into some sort of larger scale work now, but for me, we'll carry on working on these sorts of projects, partly because we enjoy them in the office, and there's often quite a lot of architecture in them for us. We're architects as well as retrofitters, but they provide, I think, a test bed and a place to learn continuously to hopefully then use that knowledge and experience in a big scale. So this is a project we finished recently. It's a Muse house in West London. I chose to put it up today because this project received an RIBA award this year. So that's not just to say, aren't I great? I'm sort of flattered that we got the award. But for me, it's sort of important that other organisations are sort of understanding the value of retrofit as part of what architecture is, a think for a long time, RIVA were very focused on a certain sort of narrow bandwidth of what architecture is. So that's more about hopefully retrofit becoming more mainstream, more visible. That's why I'm sort of especially excited. One image has fallen out here, I don't know why. Anyway, this is a slide to try and sort of remind us that retrofit is a really broad thing. You know, even designing new buildings is a broad subject, but retrofit, you're working with buildings from all different eras, different building physics. Often each building is from many different eras, there's often several different layers. And some of these projects range from sort of about 1800 to sort of probably 1930s on here. My own house, which is the missing one, sadly, is a 1960s house, so you know, not so old. The numbers, by the way, the grey numbers are the specific space heat demands as found, and the black numbers are the specific space heat demand, the number you see on PHP when we finished. So again, quite a range of numbers and a range of sort of starts and finishes. Oh, there we go. I don't know why that decided to animate itself. So yeah, that's my own place, which we finished or are finishing after about 6 years of doing stage retrofit. I think we're especially focused on projects which really aim fairly ambitious and are really sort of what I call deep retrofit. And that's a comparison of the passive house planning output of an existing building. So the stuff on the left, very big losses, very big boiler use to offset that. And on the right, that's sort of where we like to be. So much smaller heat losses, much smaller heating demand. Heating demand where it's much more viable to use a low carbon heat source. I think the other thing about owner-occupied dwellings or private homeowners are that they represent more than half of the housing stock in the UK. So a lot of the larger scale retrofit schemes today have been focused on social housing, and there are sort of obvious reasons why that's the case. But even if we were able to sort of sort out all the social housing in the UK, we'd only be touching probably 20–25% of our stock. More than 50% lies in this sort of atomised sector of private homeowners. So for me, that's one of the reasons I'm sort of remaining committed to that sector, because it has the most potential if enough of those people step forward. Motivations for those people, or my clients, are usually these sorts of things. So health and comfort, increasingly important for a lot of people, and certainly for my own retrofit, that was at least half the reason I was interested in sorting building that. Carbon emissions reduction, of course, and increasingly, for a long time we've lived with cheap fuel, and people have said, well, the payback time on all this stuff is like forever. But remarkably, in the last 18 months, that's been turned on its head, and it looks like we'll never quite return to the good old or bad old days of really cheap energy. So I'm glad, I think it's probably a good thing, though in the short term, a lot of people are going to pay a very heavy health and comfort price. So I'm going to go on to talk about sort of our approach, generally sort of moving through the key stages of the project. And for us, those are sort of assessments, which Peter spoke about, design, forming a whole house plan, to use a typo at the end, coming up with a set of measures, thinking about what the real predicted energy use is likely to be, and then through planning, and then to delivery and onto evaluation. So this image, apart from sort of an easy joke about does my bum look good in this, is me trying to say, we're really keen at the early stages of projects to get underneath the skin of buildings and understand them quite intimately, because it's often the small details which really drive the risks and drive the solutions. So opening buildings up as early as we can is really important, particularly on a building like this, which is quite complex, historic. And then converting some of that information into drawings to sort of understand how buildings go together three-dimensionally, so that we can start to think about how insulation might overlay the structure in a positive manner and in a safe manner, and in a manner which the conservation team might find palatable. That assessment involves, going around the buildings, looking at them in different ways. So thermography is often a useful technique to sort of put on the X-ray specs, and in this case we found both thermal bridges but also moisture problems were showing up through thermography. And then again, we like to try and put all that information together in some kind of record. One form of that record, rather than sort of 5 pages or 20 pages of text, is sort of a 3D assemblage of some of those observations of the building. So I think the longer we work in this sector, the more time we spend on assessment. You might think it should be the opposite, that the longer we're doing it, the easier it gets, but actually the more we realise understanding that stuff early on is really crucial to really getting to the end. So having kind of understood things, we then start to think about a whole house plan. We start to look at option improvement evaluation, and the graph sort of top right here is a page from a sort of an early feasibility stage report, and we're looking at the green bar shows kind of the base case heating demands, and then each successive vertical bar cascading to the right is a separate measure, energy efficiency measure that we've applied using acid house planning package, and we're comparing, where we start off with in terms of heat demands, where we might get to, what the overall saving might be, and we've set that against certain sort of benchmarks like social housing decarbonisation benchmark, ACB retrofit standards and NFIT standards. So clients often approach us and say we'd like to go to NFIT. We said we'll look at that for you, but let's see where we might get to. Is that realistic? Is that a safe thing to do? So all the stuff below the graph, by the way, is all the assumptions that we put into the model, which we try to articulate very clearly, because there are always lots of assumptions involved, so it's important to record those as we go. So there's quite a lot of computational stuff going on, but then there's also some architecture happening parallel to this. There might be an extension, a refurbishment, or a reorganisation of a house, and then we try and pull the retrofit stuff together with the architecture stuff and present it in a three-dimensional manner again, so that it's meaningful to us and to our clients. And so, especially our clients, they're not building professionals, and often technical plans and sections are slightly lost in them. So we always try to go back to 3D. And 3D always informs us where we've made mistakes in the areas and the stuff we've got to resolve later on, detailed design. This is another sort of simpler way of doing it, where we've shown kind of where the key retrofit measures are being applied to a building section. So insulation, glazing upgrades, M&E, heat delivery, and so on. It's a sort of a simple kind of graphic that people can understand. And at the same time, as we think about, we're often very focused on the space heat demand, because that's where most carbon is deemed to be. But we increasingly spend more and more time evaluating, is this leading to increase or continued overheating risk? So most of our projects are in central London, and I think it's fair to say, almost all houses suffer with some degree of overheating. That's just going to get worse and worse for us. So this is sort of a PHP stress test model we used on a project a few years ago. There's quite a good tool at CIPSI recently, which we're start using sort of regular sort of assessment too. So, but overheating, I think, was for a long time sort of forgotten. So key things in whole house plans that we try and get to as early as we can in the project, so by sort of stage 3 or IBA. So decide what the fabric measures are, really have a sense of how thermal continuity and air tightness continuity is to be maintained, and really starting to resolve all the interfaces, because Peter's probably recited 10,000 times that retrofit generally goes wrong at the interfaces, the junctions and the corners and so on. Having a ventilation strategy quite early on, so both one for winter and also one for summer. So one that works with the overheating, de-risking, and one which manages heat loss in winter. Designing in increasingly low carbon heat now. So until recently, about 10 years ago when we started, everybody was, the mantra was, gas boilers are the way to heat. And that's just been completely turned on its head in the last about 4 or 5 years as electricity has just decarbonised massively. It's one of the few success stories of the last 10 years. Planning in the potential for renewables, even if those follow later. And from our sort of work at UK CMP, Centre for Moisture in Buildings, we increasingly try to write down a clear moisture plan for projects really early on. So understanding kind of the existing sort of moisture profile of buildings and how the retrofit will affect those. Overheating risk, looking at whole life carbon as early on as possible too, to check that we're not spending too much carbon with retrofits, and also cost plan very early on. It's increasingly hard to do it now. Prices are stable. So delivery, we'll often try and plan the delivery of projects at quite an early stage. So we'll think about that 3-dimensionally, because the sequence of how things goes on determines how successful the retrofit's likely to be. Sometimes we'll think about stage retrofit, and so this is a slide illustrating how we approached my own house. So my own house is a 1960s building, early slide, sort of essentially a shoebox. Step 1 was to insulate kind of the long bits of the shoebox, and step 2 was the ends of the shoebox. And that's how it panned out over time. This is actually sort of a post-rationalised slide. It's meant to happen in about 3 years. It's taken about 6. But it's been quite warm, most of that. So. This is a bit of my own project. So naturally, I had quite a lot of time on site to sort of manage things and to ensure thermal continuity and to manage this roof, design out as many cold bridges as we could. The contractor participated in that process. Coordination on site for me is often about getting the holes in the right places so that things join up and ducts can pass through bits of structure. Talking about air tightness, actually this was relatively easy on our house, but there was a little bit of tricky taping to do. And then testing too, and measuring and understanding sort of where you've got to. We managed to get down to sort of passive house levels of air tightness. In stage 2, which is the sort of the ends of the shoebox, we've rebuilt those almost completely, or rebuilt the infill to the ends of our home. So we completely took the wall away. That's a view from my bedroom the day after they started. Sort of, very glorious, but we're woken up by the birds. There's the elevations going back in and the neutral glaze components, and there's somebody fitting insulation around quite a tricky cold bridge. So delivery, it's really important to spend enough time on site, checking that things are going as planned, actually carrying on that assessment process as you open up the building and find, oops, it's not quite as you thought it was. Accommodating change, so architects know that there's always lots of change when you move to the building, and managing that, managing your risk register, and ensuring that buildings are adequately commissioned and handed over at the end. And traditionally, our industry's been really, really bad about that, and it's especially important for retrofit. So finally, a bit about that evaluation, so Peter flagged that up as being really important in terms of closing the circle and trying to avoid just carrying on making the same mistake again and again, which is what Retrofit's been doing. So this is a summary of the project at the start of the show. So measured build data on the left-hand side, the full retrofits, our PHP prediction in the middle, and then what we actually ended up with afterwards on the right-hand side. So actually the heating and hot water did even better than we imagined. The clients ended up using more electricity in the house, but pretty much on target, and sort of 80% and 90% sort of reductions depending on the sort of figures you look at. This is another house that the clients measured the energy use for 9 years, and you can see it's not changed, which is encouraging. The air types hasn't fallen apart, the insulation hasn't blown off. So very, very low space heat demand, close to retrofit levels, quite good PV input, offsetting quite a lot of electrical load, and nice sort of flat lines, fitting in well with the LETI, recent LETI guidance, and sort of almost sort of matching up to benefit. This is a building, of course, with a boiler and a heat pump. Think about embodied carbon, I said earlier on. So again, the project at the start of the show, we tried to sort of assess how embodied carbon went in. And sort of pleasingly, most of embodied carbon was in the energy saving measures. We managed not to spend too much on kind of the other stuff, finishes, the timber structure and the steel, which I've called loosely the architecture. So you kind of want to be spending on the green stuff if you can, because that's where. And again, comparing this whole life carbon in 60 years. So if that building carried on business as usual, you'd be looking at the orange lines, but assuming it carries on as per the first year, the green lines, the dotted lines, by the way, if the grid really decarbonises totally by 2035. So we actually head very quickly towards a flat line. And the important bit, really important bit, is where the red circle is. When do those two lines cross? Because we spend a carbon burn at the start of the retrofit, sort of spending carbon. How quickly do we sort of make that back through the efficiencies in the operational carbon? And we want that time shift to be as little as possible. 2 to 3 years ideally, not 10 years, because we've only got less than 10 years left to try and sort things out. Right, that's me. Thank you. Just a couple of minutes over.
Thanks very much, Bob. That was great. Really good example of how to do it, how to put to achieve good quality retrofit in practice. What I didn't highlight to the virtual audience is that please can you put questions in the chat, so that we'll be monitoring the questions and we'll share questions between the virtual audience and the audience here in person. Next, we've got a number of speakers from Energy Conscious Design, ECD. We've got 2 of them in person and 1 of them remotely. We've got James Traynor, who is the director of ECD, joining us remotely. In recent years, he's been involved in a number of pioneering refurbishment projects. I should have said first, ECD's I've got a very long established record of working on sustainable buildings, designing sustainable buildings since the 1980s. James will introduce his 2 colleagues who are here in person. So over to you, James.
Okay, thank you. And thanks for inviting me this evening and my colleagues. I'm here obviously to talk about large-scale retrofit. So it's really interesting to hear about small-scale retrofit from Bob, and obviously past 2035 and the future direction of that. Brilliant. Okay, so this evening we're talking about 3 projects that we're involved in at the moment. all relatively large schemes, which are either deep, medium level or standard level retrofits for a variety of clients, and touch on many of the issues that have been raised already this evening. But first, if I can talk a little bit as an introduction to where we are, that's us. So I'm an architect, and Claire is my colleague at ECD, a technologist, and John Abbott is also a colleague from our sister company, Keegan's Surveyors. All three of us are retrofit coordinators, and we're involved in different stages of the project. John is also a retrofit assessor, and Claire and I are retrofit designers. So a little bit about us. I think the important thing, just go back one. Sorry. Important thing to say really about retrofit at scale, and it's probably the same at small scale as well, but particularly on large scale projects, is the diversity of scope really, I suppose. It's fair to say, although PAS 2035 methodology is very clear, every client is coming to it with a different set of buildings and a different level of knowledge, and often very different levels of data held. Some have very poor levels of information, quality of data. Some have very good levels of data. So some projects are driven very much by external funding, government funding, whereas others are driven by resident desire to improve or address issues such as fuel poverty. There's also a wide range of understanding as to the extent of consultation required. So we have some projects that are very consultation heavy, very much about co-design, and rightly so, a process of working with residents to work out what is appropriate for their homes. Whereas others, it's a more, I'd say, traditional is perhaps the wrong word, but they're coming from, the projects are perhaps coming from a background where previously works were done as isolated packages of external wall measures or window replacement contracts. And obviously with PAS 2035, as Peter has outlined, it's about bringing those together in a whole house holistic solution, which is incredibly important. But it's a new thing for many landlords to get their head around. And so the first thing to say is we're really, the expectations, I suppose, of the housing industry, the construction industry, are very wide indeed. And in terms of the performance standards that we're working to, we have some projects that are NFIT standard, like the Wilmcote House and James Riley Point, and we've got others, and Energy Sprong, which is similarly a very high standard, exacting performance standard, whereas others that are much more traditional in the sense, a lower standard, eco-funded projects, and somewhere in the middle we would have the SHDF, social housing decarbonisation funded projects, which have emerged over the last couple of years. So I'll have to take the next slide. Yeah, that slide really just shows the space heating demand of the average home in the UK, in the orange bar there, and the dotted lines there show the performance targets for various SHDF funds that have been released over the last couple of years. And so the projects that we're involved in now have to reduce heating demand to that level, but it's important to say that obviously these buildings will continue to be owned by these landlords for many, many years, and that's really the first step in reducing the demand. So it's 90, in this case, 90 kilowatts, which is the wave one target shown on the right hand side there, should be seen as the first step. It's certainly not anywhere near a net zero carbon outcome. So the drivers for retrofit are clearly carbon emission reduction, global issues, but they're also human issues as well. So if you take the next slide, fuel poverty is increasingly an issue, and it will particularly this year. As you can see, the gas prices, that's just from the end of last year, showing the spike, and it obviously hasn't gone down since then. And the elephant in the room, the fact that 87% of our homes are using gas as their main source of heating. So that will change, but it can't change overnight, and it can't change without dramatically improving or reducing the heat losses from those homes. Take the next slide. And it's also just to say it's a massive opportunity as well for us all in the construction industry and the housing industry to tackle this. And this is a graph that was put together a few years ago by New Economics Foundation about the potential growth in the UK construction industry. And you can see the light blue at the top is the Retrofit Coordinator role emerging over time. And it's not grown, as the profile shows there, quite as rapidly as it's shown there, but it certainly is growing. Funding is starting to make a difference, although it's still far short of what we need as an industry. And the SHDF fund, which I referred to, is nearly 4 billion over the next 10 years, and that's ramping up, but there will need to be more, and it will need to tackle other sectors as well. So next slide. So this is just a project that we're working on at the moment, which is a deep retrofit project, which is Enefit or near Enefit standards. One of the projects is Energiesprong level standard for the Lancaster West estate, which is the estate to which Grenfell Tower belongs. As you can imagine, there has been a very lengthy period of consultation with residents, and obviously for those of you who've read around heard the outcomes from the Grenfell inquiry, not completed yet, but the issues that have arisen there in terms of many issues, but one of them being the very, very poor information provided to residents through the previous refurbishment of the Grenfell Tower. So the landlord, Kensington and Chelsea, and the Lancaster West estate team, they were particularly keen to ensure that in refurbishing the homes, making them low energy homes, that they were very much consulted as part of the process. So that's what I suppose I say that would be the high watermark, the most intensive consultation process that we've undertaken, but for obvious reasons. But also one of the most demanding in terms of energy reduction targets. So there's a variety of schemes here. One is SHDF funded. That's the scheme there, which is Talbot's Grover Moorland House, and we're looking to reduce the heating demand down to about 50, which is a significant drop. It's currently on an existing heating system. And that is actually leaking heat and causing overheating problems. But it's a 1930s mansion block. It's not listed, it's not in a conservation area, but it has architectural qualities that we would want to retain. So we've looked at the existing space heating demand, which is extremely high, as you can see there, model and PHPP, and looked at options to reduce that, and considered whether it's ultimately the AECB or Enefit by component standards that we go for, but it's going to be a deep reduction alongside a new low carbon heat network as well. One of the other projects on that estate is the Treadgold House project, which is a 1950s block, deck access, and that one has received EU funding through the Interreg programme, must be zero, and the contractor is required under Energiesprong, for those of you who know anything about that, is to provide a performance guarantee on actual performance. The contractor has recently been appointed, and that one is going on site soon. That's it. And that's just to recap on what I was saying about the level of consultation and co-design process. And there's a lot of information actually available online about this project through the wearew11.org social media program, and the website there, that showing the kind of consultation that we've undertaken through the course of the work, workshops, videos. Even through the depths of COVID, we were going out doing videos on the estate talking about ventilation how to tackle heat loss in buildings, talking about some of the geeky, techie stuff about thermal bridges, but not putting it in layman's terms, and talking about sort of the real problems that people were facing, the damp, the mold, and how we were going to tackle those. So it's traditional media, traditional approach like door knocking, but also modern methods, including all the social media, etc. So I think that's it from me. I'm going to hand over to Claire now, who's going to talk about one of our projects for Milton Keynes, which is a medium level retrofit, I would say.
Great. Hi, I'm Claire Raftery. I'm an associate and retrofit coordinator at ECD, and I wanted to talk to you today about a large-scale mid-level retrofit that we're currently working on with BEIS, which is Netherfield Estate. So Netherfield Estate was designed and built in the 1970s and was one of the first completed developments in Milton Keynes new town. The site covers 6 roads running northeast to southwest and has over 1,000 dwellings on the site. The houses are timber construction for all external, internal walls, floors and roofs. This allowed properties to be built quickly with semi-skilled labour, responding to demand for housing at the time. The topography of the site is sloped, but there's a common roof line across the estate, giving variance in architecture. Vertical GRP fins on the front facades provide privacy and a unique modernist view down the road. Through SHDF funding, ECD and Keegan's have been asked to look at the retrofit assessment, coordination and designer services to 302 properties. When working on retrofit at scale, one of the first tasks is to identify the architects. As mentioned, the site is sloped with a consistent roof line, giving us a mixture of bungalows, 2-storey and 3-storey properties. Overall, we identified 7 key archetypes and a couple of sub-archetypes. For each property, for example, bungalows, we have a mid-terrace and an end-of-terrace property, and each of these provide a different heat demand. Once archetypes have been established, we can look at the buildings in more detail to understand where they're not performing. The retrofit assessor will carry out an assessment for each property, which starts to build us a picture. We can then put together PHPPs of the existing archetypes. The assessment and PHPPs identified our key heat losses were through the walls, roofs, windows, and through infiltration, as you can see in the graph there. There was also significant heat gains through the glazing. Another challenge is the GRP fins between each property, which will make installing EWI quite tricky. Netherfield Estate has received funding through SHDF Wave 1 and therefore has to meet funding criteria. As part of this, we have to outline what the intended outcomes are. So this is reduction in energy cost and alleviation of fuel poverty, reduction in emissions associated with energy use, improvement in internal comfort, key 1 meeting performance standard of 90 kilowatt hours per meter squared per year, reducing risk of overheating, elimination of condensation, damp and mold, and a reduction in energy use. As mentioned previously, the key measurable criteria for SHDF is to meet 90 kilowatt hours per meter squared heat demand. Under PAS 2035, we use design SAP to produce proposed EPCs for each property, outlining the measures to form part of the medium-term improvement plan. Design SAP is a very useful tool for working on a large number of properties. However, for accuracy, we've also created PHPP models to model the different scenarios. The existing PHPPs showed a heat demand ranging from 141 to 290 kilowatt hours per meter squared, so significant reductions required. And you can see in this table that we have here, these are the various measures that we modeled to understand how we can meet that 90 kilowatt hours target. As an overall strategy for the retrofit design, we agreed with our client to design to the worst case scenario, which for Netherfield is an end of terrace bungalow. Properties with better form factors can then benefit from an even lower heat demand. The reason for this is to simplify the number of systems being installed on site to achieve economy of scale and improved quality of install. The measures required to achieve 90 kilowatt hours on a bungalow include new external wall insulation, new high performing windows, new flat roof insulation, a reduced glazing area and an improved G value. There's also below ground insulation around the perimeter of the building, new through wall heat recovery units. We weren't able to do extensive work internally, so therefore we couldn't install a full MVHR system. However, we were able to install localized heat recovery units. And then we also have to remove the GRP fins, insulate behind them, and put something else back. And this is where we're at now with the proposal. So we've got new EWI, weatherboarding to the ground floor, and our new fin design, which, as you can see from the image on the left, we're going to have a mixture of properties that are in scope and a mixture of properties that are outside of scope. So it's key to try and find something that modernises the site but can also be linked back into the original architecture.
So yeah, I'm John Albert, Keegan's Retrofit Coordinator and Assessor. So this really, we do, we've been going out to do a lot of large scale projects. The one we're talking about now is in Hull. It's 853 properties. Obviously, on this sort of scale, the issues really, vary from. One of the major problems is gaining access. There's a lot of arranging to try and get into properties of that sort of number. There's, I guess, a real learning curve for not just ourselves, but the contractors involved and the council involved. When we first started this project, they really only they wanted to just do EWI, nothing else. So we had to sort of walk them through, talk them through the process and try and encourage them to look at windows, obviously ventilation, and also the loft insulation. And over time, it's, they've understood and they've kind of, been brought along and been educated. So now they're actually looking at doing full windows, full EWI, new doors. We weren't working with ECD as designers on this, which sort of caused some issues. Having sort of worked with ECD in the past is, we know how each other work. When we've come along to this, they've opened up a certain, project, pilot project, and as you can see in this property here, you can't really see from this, but what's happened is when these windows were retrofitted a few years ago, they cut the timbers along here, and so actually this is bowing. So that was only discovered from doing the pilot. I guess, yeah, so the methodology that we're following, I think everybody's really talked about it. We do the retrofit assessment, and then, that then formulates it's really three parts. It's the RDSAP, which is the energy report, it's a condition report, room by room, and it's an occupancy. Once we've gone in and done all these three reports, we take the data from the energy report and we run it through design SAP to give us a base model. So that will give us a heat demand for that specific property. One of the things that we find is very important on large scale is trying to, we've identified through, looking at all the properties, what the archetypes are in order to maximize and sort of get the efficiency. What we try to do is do floor plans for each of those archetypes, and we'll model each of those archetypes. And then we might have 5, 6 or 10 assessors going out. What we try to do is get them to have one floor plan that they'll work to for that specific archetype. So they'll go in and they'll know the measurements, but they'll need to double check them, make sure that they are the same. That then helps us going forward with our design SAP, although each property has to be done. There's a lot of kind of resistance with the councils and housing associations. They sort of believe that you shouldn't have to go into every property. Why can't you just do the archetype and that's it? But there's obviously a reason why we have to go into every property, because there could be damp issues. We have to identify those, and that needs to be resolved before it goes on to the next stage, really. So this is the condition report. So we'll identify any issues that we see. We see some damp here. So before the contractor goes in, starts work, they have to really resolve any issues, any sort of standing issues, and that formulates the report for them to be able to really understand that property as an individual property. So the midterm plan is we've spoken about it before. It's basically you're taking all of your measurements from the baseline. You do design SAP for each measure that you're going to implement. One for the windows, one for the EWI, one for the roof insulation, and you then add them all together, and it will give you the reduction in carbon, your reduction in heat demand, and the risk matrix here is basically just making sure that each measure you're adding in isn't clashing. So it just it gives you that assurance that what you're doing is correct. So this basically it shows you where your costs are for each measure, and how that can reduce your heating, hot water, electricity demand. And that's basically just going through the different measures now. So lessons learned. The important thing, as I said, is like trying to understand these archetypes, sub-archetypes and variants. It can be quite confusing because you have a mid-terrace, you can have an end terrace left hand, end terrace right hand, but then you could have one that's got an extension on the back or slightly different. So it can be very, we can end up with probably 80 different variations and trying to work that out. Sometimes it's almost best, on some projects, we've realised it's best just to forget about the archetypes and just survey them all as individual, because it's just so, so complex. But where we can, it's really good to define that. And hopefully, as Peter said, somewhere in the future, things might change with the PAS 2035, that they might relax somehow or change this need to, necessarily. I mean, I don't know if we always have to go in and do a condition survey on each property. I would think that we do, but somehow maybe that will change. So there's always, what we've come across so far in every project we've done, there's certain aspects that always seem to be a problem. And especially working on scale, things like the meter boxes, having to try and persuade the council or the contractor to, insulate behind the box, or certain elements, it's quite a struggle, really. So what we do, or what we have to do, is where we've come up against a risk, we have to do a calculation, side calculation, to try and mitigate that risk, or try and define whether it will actually cause condensation, damp issues. So a lot of the, if you've got a block of mid-terrace, a terrace of properties and one or two council properties, you've got to understand, well, what happens on the party lawn where the council property is being insulated and the private one isn't. So again, what we have to do is really calculate that as a side calculation, make sure it's not going to make things worse. And typically, what is recommended is that you do internal insulation, but it's not always possible on these projects. We're talking on scale for hundreds of properties. The cost of that, would be astronomical. So, That's well done.
Thank you very much. John and James, very comprehensive account of working at scale on retrofit. We're now moving to questions, but we've got Lisa. I hope we've got Lisa Pasquale joining us, who is from Retrofit Works, and she's responsible for their overall strategy, their technical strategy, Retrofit Works for domestic projects. She's a trained architect and a chartered civil engineer with over 10 years experience in low energy construction and building performance. Okay, so we'd start with a question from the virtual audience. Augustin?
Start at the top. I think that first question is to Peter, but I think he may well have already answered it in his presentation, but it's probably good to ask it again.
Should the role of retrofit coordinator be separate to that of the contractor for past 2035? Who asked that question? Oh, I don't know who that was. Yeah, well,
and architect. That's my question. Separate to the architect.
Yeah. Oh, and the architect. Should they be separate from the contractor and the architect? This is a question for Peter.
Okay, well, I think my view, which is not the same as the official view, is that the retrofit coordinator should never work for the contractor or installer. The role of the retrofit coordinator is to protect the client's interest and the public interest. Therefore, in all the work that, for instance, I've been doing with Savills, we've been trying to get the retrofit coordinator on the client side of the contractual fence. We've also beginning to think, well, it's very difficult in social housing to get the social housing organizations to accept that the designer could be on their side of the fence because they don't want to take liability for the design. So they're very keen on keeping design and install type contracts, and we've been not very successful in persuading them out of that. However, we think that there's a lot to be said. Well, sorry, one of the things that PAS 2035 allows is that people who are suitably qualified, for example, some of the ECD people we've heard from, who are both retrofit coordinators and designers, can combine the roles. And we think there's a lot of merit in having a retrofit coordinator who's also the retrofit designer, or a retrofit coordinator who's also the retrofit assessor, especially if those people have particular experience of real retrofits. So I'm a great supporter of combining the roles. I'm a great supporter of retrofit coordinators being independent. At the last update to PAS 2035, sorry, the last amendment to PAS 2035 at the end of last year, we inserted a clause that says that it is recommended that the retrofit coordinator is not employed by the retrofit installer. That's not a requirement, it's a recommendation, but one of the objectives we have for this year's update is to try and convert that recommendation into a requirement. It depends, of course, on the steering group, but I think there's a sort of body of experience with retrofit coordinators in the bigger projects that's leading us and many people to conclude that we should try and get some independence for them. So it's not a very clear answer, but I think the direction of travel is a good one.
Thank you very much.
The SHDF target, which is 90 kilowatt hours per metre squared, Matthew Tully says he thinks that that means that the work will have to be redone at some point, and that it's a shame it's quite a low target. So we're kind of getting into the realm of he also reckons that to run a heat pump, it will cost a lot of money.
Should we ask James maybe to do that one?
Yeah, I'm happy to take that one. And I know exactly where the question is coming from. I think, obviously, the first round of SHDF funding, the target was 50, and it was relaxed to 90. And there was many of us who thought that was probably a bit too loose, a bit too low as a standard. I think the role of the retrofit coordinator is to ensure that there, and in fact, it's enshrined in the SHDF funding criteria that there should be no regrets, and the measures that are proposed should be appropriate and not be require reopening or replacement within the lifespan of that material or on the road to zero carbon. So what that means is that where we are trying to achieve 90, we typically the full, say we're talking about wall insulation, would go with the full thickness of wall insulation and windows, let's say, because that's a bit like Bob was saying earlier, focus on one element and get that right, and then come back to do some other elements of the building later, so that you're not unpicking a little bit of everything every time. So that's our advice, and obviously as retrofit coordinators, is what we're trained to do as architects and as coordinators. So I think 90 for a bungalow a detached bungalow can be quite challenging. For a 3-story mid-terrace house, it's not challenging at all. So if 90 is your minimum and you're a landlord with multiple properties, just like the Milton Keynes one, we're achieving with the same specification 90 on the bungalow or just below. The same specification is circa 50 on the 3-story houses. So that's the way it works. So it's actually better than it sounds.
Thank you. But I think it really comes back to the whole house approach, doesn't it? And doing it in stages that I think is integral to the approach that's being put forward this evening. Do we have a question from the audience now? Chris?
I have a question really for Claire, maybe other people with modernist projects. In Milton Keynes, you talked about quite a big project with 780 houses or
300 in the first wave, yeah.
So you didn't talk about orientation. You didn't talk about south, east, north, and those big bands of glass. If it's south, you could easily do brise soleil or trellises, and I didn't hear anything
it's
about
not something
cooling.
that I touched on in the presentation. We do actually have solar shading to the rear facades, and on the front facades. Over time, the properties have had various upgrades, and some of them have already had their glazing reduced from a full width banding to 3 panels in the centre. And our strategy going forward is on all of the properties to reduce the glazing down to the centre pane, so that we naturally get less glazing on the front, and then on the back where the windows are already narrower, we're then adding solar shading as well. And from the PHPP calculations that we have run, only a small amount of solar shading was then needed to ensure that solar demand was reduced sufficiently. So it has been considered. I just didn't touch on it in the presentation.
Yeah, just another follow-up with those big flat roofs. For me, it's so easy to put solar on. Is there?
So it's part of the medium-term retrofit plan. But not part of the SHDF funding. The solar panels wouldn't be funded, and therefore it's not something they're going to pursue at this time. But everything that we're doing is allowing solar panels to be installed at a future date. So yeah, that was one of the things that we wanted to do, but we can't do it under this current wave.
In the coordination midterm plan, we'll phase it. So phase 1 would be the SHDF funded work. Phase 2 would be, solar and possibly other heating and various things, So that's the way we tend to look at these things. It's not just one phase. It's over 30 years, or over a certain period of time.
Thank you very much. We've got another question.
Yeah, I guess my question sort of continues on that. Have you managed to sort of combine different funding schemes for the same? Let's say like for ventilation after doing the fabric upgrades, and then PV panels, for example, with another funding. Maybe have you tried any?
So not on this project. No, we've just got funding through SHDF. However, on one of the projects that we're looking at installing insulation to the suspended floor using a robot that goes into the floor cavity. And it's potentially we can get that funded through an innovation fund. So we're going to have SHDF on those projects, and then potentially also a top up from an innovation fund?
On the whole project as well, some of the properties are SHDF and some of them are will be eco for. So it's not quite combined, but it's sort of split between the project.
Thank you very much. Shall we have another question from the virtual audience?
Yeah, so this one came through to Bob's presentation from Matthew, which is any idea of improvement home value after retrofit? So how much of additional cost is covered by higher home value? And that's probably asked factoring out the additional value created by architectural design. So specifically, it's not priceless, but specifically about the retrofit elements of it.
There's not much evidence, but I think there is some emerging evidence. I think it might be through Samuels actually, Peter might know, where people do seem to be prepared to pay a premium for homes which can be retrofitted and homes which have got heat pumps and so on, because the purchaser can clearly see, there's thousands of pounds which they're not going to have to spend in a few years. So that seems to be becoming evidence. From a personal perspective on my own project, we've had the house values, which is of interest, and it would seem that our investment will be paid back. Now, some of that I think is kind of the architect's stuff, because some of the spaces before we intervened were not very nice. But I think some of it will at least half of that will be because it's very low energy, very high comfort of the owner, and I think that's kind of quite evident. So I'm optimistic that there will be increasing evidence to support that.
Thank you. Peter, do you want to come in on that?
Well, I just wanted to say, really, it's a no-brainer, isn't it? If you double the price, you halve the payback period. So it's putting fuel prices up has always, despite the pain associated with fuel poverty, has always been the way to make retrofit more attractive. And somebody else earlier said that it's a painful process, clearly, but it's probably the right direction of travel. We need to make energy so expensive that people don't want to waste it. And we haven't quite got there yet, I'm afraid, but we may be getting there soon.
Do you want to come in with that message?
Yeah, Leanne Edmund has said that they've had a valuation done on an energy strong project in Nottingham, and it increases the value by 25%, they think.
Wow, that's impressive.
I've got another fun house price fact, which is the BEIS heat and building strategy in October 21. They sort of state that houses with an EPC rating of C will worth around 5% more than those currently rated EPC D, after controlling for other factors such as property size and archetype. So it's great, like I said, it's great evidence.
Good, thank you. Shall we have another virtual question?
There is one that was.
There's one in the room while we.
Okay, shall we have one? Is there any more questions from the room?
Well, I want to ask, you do a lot with your private clients, and you obviously do quite extensive research, whatever, into the buildings and then modelling, etc. And do most of your clients come to you with that they want to do kind of a deep retrofit, or do they come to you going, I want an extension, and you kind of persuade them into doing a retrofit, as it were, and how those conversations work?
So most clients come to us with a brief, which is usually about renovation or extending, and the pennies dropped from them. They realise that's the time to fit the insulation, so they're quite keen to pursue a retrofit strategy. So there's always, I think, almost all the people that approach us, are asking for those two things. And then to sort of turn your question on its head a bit, then we spend time trying to get them to do less extension and make the space work better just through good design, and not spend all the money on that. So there's enough budget left to do a really good retrofit. and we don't end up spending too much on embodied too. So steel work, concrete, and ground extensions. That's where all the carbon is actually. The insulation, the windows, and so on is much lighter.
I suppose the flip side of that is kind of your time and your fees. It's obviously quite involved doing your whole process that you talk through, and whether you have to kind of carefully tread around those moments with clients as well. I'm just kind of going your. I don't know, say you go to, I don't want to be crass, but a typical non-defined architect that does an extension and maybe a bit of rejigging in a house, but doesn't go through the kind of carbon modelling and thinking about all the different factors that you do quite detailed research into how the building.
I think it's fair to say that our fees are a bit higher probably than people offering similar services without the green stuff.
Yeah, that's what I was kind of.
But because somebody would have to do some sort of house assessment, they have to do and get some measure drawings prepared. They have to do some design work. So that architectural bit that's already getting spent is probably most of the fee.
Yeah.
And it's a bit like the cost of the build actually. Most of the money is going on renewing the electric system because it's knackered. But when you're doing that, that's the time to fit IWI. So I think our kind of green stuff fee kind of rides piggyback on the architect stuff, and it's a bit more. And some clients say no, that's really cheap then. Do that.
Yeah, no, I'm just.
But I don't think it's not a game changer.
Okay, thank you. You have another question from the virtual audience?
Yeah. Well, this was a brief one, which was about the way that we model. The question is it SAP or is it PHP? And I think Jonathan, you were
we use SAP
and Bob using PHP. So
and we use both.
okay. And maybe Claire, can you
one of the requirements from PAS 2035 is to produce an EPC for the proposal for every single property. And in order to do that, we use Design SAP. It's quite a quick tool to use. We can fairly quickly model things and get a space heating demand output. However, it works based on some assumptions, and those aren't always as accurate as a PHPP model. So therefore, what we do is we model the archetypes in PHPP. This is on a larger scale project, and we model the archetypes in PHPP. We get that really accurate strategy locked in, and then we do a design SAP on every single property to fulfill the PAS 2035 requirements. So we do both.
And is there a difference in the figures? I mean, what somebody here said, what does 85,000 kilowatt hours per metre squared per annum? I'm not quite sure if that's what they meant to write.
85,000 would be very high.
The question was if it said that in SAP, if SAP's saying that, what would the difference be in PHP?
I mean, it's not that easy to give a direct comparison, but we are noticing that SAP is often a bit optimistic about what you have achieved, and the reality when you model it in PHPP, the heat demand is higher, and therefore we use that as a more accurate basis, because we can look at a building and sometimes an EPC might kind of say, oh yeah, that's around 100, and then we model it in PHPP and it's getting more like 120, and then we know, right, okay, there's still work to be done there to bring that down.
I was going to dumb that question down at the end, which was, do you have a favourite?
I think in ECD, people like PHPP quite a lot because of all of the data that you can put into it and extract from it. But I think as we do more and more retrofit projects at scale, design snap is going to become our friend, because we can't do a PHPP model on every property. It wouldn't be viable.
It's much more complex, isn't it, to do
Yeah.
PHPP? I mean, you know, RD SAP is a blunt tool, but it just gives you something to sort of compare against, really.
Yeah,
And,
both are
you know,
necessary.
yeah, definitely. But PHPP is much more detailed, and it gives you all of your, you know, it goes into much more detail on your heat, you know, your heat loss and your thermal bridges, whereas SAP doesn't really.
Yeah. And it produces some lovely graphs to give to the client at the end of it.
We're running over time, but I think, should we take a couple more questions?
We've got one question from Matthew Club, who I think is in Scotland, and he's saying we clearly need more lobbying power in getting our governments to take deep retrofit more seriously. Do the panel have any ideas on this, and whether lobbying local authorities is more likely to succeed? And are there any success stories?
Who'd like to respond to that?
I can answer that. I mean, lobbying always helps. I suppose for us, it's been taking people on a journey, and in terms of success stories, I can talk about, you know, clients who'd never heard of passive house or deep retrofit and came to us with angry residents and who are in serious fuel poverty, and now they're doing all of their properties, new build properties, passive house, and all of their retrofit. They're targeting NFIT or AECB. So, and that's large local authorities. So that's Portsmouth, to name and shame, or name and praise. But there are others as well that over the years have sort of seen the light, if you like, and see that actually, now that particularly as energy prices are rising, it makes sense to do it properly. And even if they can't afford to do everything in one go, then understand where they're trying to get to and model it properly. So I think there's lots of individual positive stories, but and there's positive signs. The Scottish government are increasingly looking towards passive houses as the future for new build standards, and NFIT and AECB is increasingly well known. Whether it's actually adopted, I don't know, but certainly it's heading the right direction. But in England and Wales, well, England at least, I think it's a bit more patchy.
Well, I'd quite like to add to that, I mean, I think for England and Wales, with this government, forget it. You know, I know I've been working with some civil servants in BEIS recently, and this is completely off the record, but they're actually working on policy development for the owner-occupied sector, and their target is to have it ready for the next government, because they know this government will never do it. But there are some great ideas out there, and nearly everybody in the academic world looking at this stuff from a strategic point of view is saying you'll only get to grips with the owner-occupied sector through sticks and carrots. And one of the best ideas I've heard is Brenda Boardman's idea that we have minimum energy efficiency standards at the point of sale for the owner-occupied sector, perhaps racking up by a band or a certain number of SAP points every 5 years, but all published in advance. And the purpose of that would be to ensure that the market prices in the cost of retrofit when people buy houses, because when they do, they'll know that they have to improve it by the end of the next band. So there are mechanisms like that which are market driven. At the moment, the Treasury is way off base in that respect, but there's lots of good ideas out there waiting to happen. So I think it can happen. And then picking up what James said a few minutes ago, but I'm a great believer that if we're going to do 27 million retrofits, it has to come from the grassroots. And I think programs like URBED, carbon co-ops, people-powered retrofit have lots of lessons for us about how to do it. And I think the next step up from that is local authorities. Local authorities are much nearer the action. They're not much nearer the circumstances of the households. They're the people to promote and help to deliver retrofit locally. Forget central government, they don't know what's going on. So my view is, yes, the more local, the better in this.
Thank you very much. Do you want to have one final question? Well, there's nothing else. Anything standing out in the room? Well, I think then it comes to me to thank everyone. Also, if people would like to become more involved in ACAN, and particularly in the existing buildings group. And I hope that the WhatsApp link will be put in the chat for people who are virtually there. Just to give you a bit of an idea of what we're doing in the existing buildings group, we've got lots of projects underway at the moment. Chris is working on a climate emergency toolkit for conservation areas. We've been working with campaigning with Households Declare for and with the New Economics Foundation for a national retrofit strategy. We're involved in organising a retrofit festival in Birmingham and research on the extent to which planning is an obstacle to implementing retrofit. Obtaining planning permission is an obstacle to obtaining retrofit.
The Birmingham event is probably on Civic Square website.
Well, we can put some. We can do an email with some of these links through the people who joined from Eventbrite. Whether they're here or not. So we can do. We can send out an email with links. So many thanks to our panel. Been great presentations, great response to questions as well. So thank you very much.